This is Goodwin Island in Virginia. You can see here down the coastline that is slowly eroding. And then if you look off this way, there is the salt marsh that is slowly replacing the forests that were once there.
Scientist Tyler Messerschmidt explains that trees cannot live in the wet, salty ground from sea level rise and storm surges in the York River. Because of climate change caused by humans, the water is getting warmer and expanding. Where thriving trees once stood guard, he says we have ghost forests, and they make climate change even worse.
These forests are great stores of carbon that are there, and as those trees slowly die, that carbon is returned, some of it to the natural system, including the atmosphere, which also leads to possibly more global warming through climate change.
Marshes like these help keep the base clean. They protect against the wrath of hurricanes, but they too are drowning. They have the capacity to migrate inland to protect themselves, but development along the coastlines is leaving them nowhere to go.
Bangladesh, parts of India, Thailand, a lot of Thailand, Myanmar, Vietnam. These have large stretches of marshland, which is in the tropics. Mangroves are a dominant species, and we're eroding away the base of those systems.
I'm going to go ahead and lower the net.
Scientist Deborah Steinberg tows nets to collect samples of other organisms that are relocating because of climate change.
Oh, you can see them. Yeah, so those are copepods, rice grain size crustaceans, and they're sort of a central part of the ocean food web.
In what's called the biological pump, they help sink carbon dioxide, the main global warming gas, to the depths of the ocean.
If we didn't have the biological pump, then the atmospheric carbon dioxide would be 50% higher than it is now. And if we have higher carbon dioxide in the atmosphere, that causes more of a greenhouse effect, and that's more warming.
The warming has changed where these marine drifters operate.
We have tropical and subtropical plankton that are expanding their range away from the equator, and then the subpolar and polar species, their ranges are contracting. A lot of the tropical, subtropical plankton are smaller, and so they're not as efficient at transporting the carbon.
Scientists around the world are monitoring these negative effects of climate change. They are also working hard to help nature heal itself. As part of the efforts to restore foundation habitats, scientists collect seeds from seagrasses to use in restoration projects. The species known as eelgrass also absorbs carbon. It was once abundant in the Chesapeake Bay, but it's dying back from high temperatures. Biologist Christopher Patrick and his team are hunting for answers.
Rather than just plant eelgrass, we're also planting another species. And that species is another native seagrass that's in the Chesapeake Bay called widgeon grass, and it can handle high temperatures.
The ultimate hope is that the two species will help each other survive and protect other creatures at the same time.
Juvenile fish and crabs, they have higher abundance, they have faster growth rates, and they survive better in the grass beds than outside of the grass beds. And so it's performing this really important service for the fisheries.
During the fall of 2021, widgeon grass seeds will be planted for the first time on a large-scale restoration project near Virginia Beach. It's a project that could be a model for ailing shorelines around the world. Verónica Valderas Iglesias for VOA News, Gloucester Point, Virginia.